In this section, I'll be looking at how the emissions from these processes can affect your body and highlight the need for fume extraction. As Ross has mentioned, two key categories of contaminants on these types of processes are particulate, usually in the form of nanoparticles, and gas. We'll start by looking at the particles. On the screen, you'll see research that shows how particle size affects how far into the human body they can penetrate. I'm going to be using the term micron in this section. For those that aren't aware, 1 micron is 1,000th of a millimetre. 30 microns is roughly what you can see with the human eye. 10 microns, particles start to enter your mouth and nasal cavity. At around 5 microns, particles enter your respiratory tract. At 2.5 microns, they can enter your lungs. At around 1 micron, particles will reach the very extremities of your lungs. If you remember from the previous section, the majority of particles generated by processes like filament printing are even smaller than 1 micron and have the potential to get right into the extremities of your lungs. And as we'll see on the next slide, potentially even further. This is some research that has been conducted into the health effects of nanoparticles. I'll just read the quote from it. Insoluble or low solubility nanoparticles in biological fluid are the greatest cause for concern. Because of their tiny size, several studies have shown behavior unique to nanoparticles. Some of them can pass through our various defense mechanisms and be transported through the body in insoluble form. Thus, some nanoparticles can end up in the bloodstream after passing through all the respiratory and gastronomical membranes. They are then distributed to various organs and accumulate at specific sites. Others travel along olfactory nerves and penetrate directly into the brain, while still others pass through our cell barriers and reach the nucleus of the cell. Several effects have already been shown in animals. Among these, toxic effects have been identified in several organs: heart, lungs, kidneys, reproductive systems, as well as genotoxicity and cytotoxicity. This shows that emissions from 3D printing processes have the potential to reach much further into the body than conventional processes. It highlights insoluble nanoparticles, which I'd expect plastics from 3D printing to be. Next, we'll talk about gases. Your lungs have roughly the same surface area as a tennis court, which gives them a huge capacity to exchange chemicals between the air and your bloodstream, especially if those chemicals are water-soluble. There are a wide variety of illnesses that can be caused by breathing in contaminated air. The more severe ones, like cancers and pulmonary disease, are of the greatest concern. But the more common ones, like headaches and skin irritations, can be very unpleasant and, if left untreated over time, can turn into more severe illnesses. On screen is data taken from the UK Office of National Statistics. If you're listening from outside of the UK, we have a population of just over 65 million, so you can scale these numbers appropriately. One of the key takeaways is that an estimated 12,000 people die every year from workplace-related lung disease. This shows how important it is to understand and control the air that you're breathing in. By reference, less than 2,000 people die in the UK every year in car incidents. Despite the death rate being for occupational lung disease being 6 times higher, everyone knows you need airbags and a seatbelt. Not everyone knows you need fume extraction. Next, we'll look at the laws that are in place to protect 3D printer users. Every country has its own set of regulations, but many of them follow the same framework. The first step is to make it the responsibility of the employer to look after the health and safety of everyone on their site. You can see examples of this from across the world on your screen. This includes employees, subcontractors, or visitors who have just come in to see your new 3D printing system. It is the responsibility of the employer to look after their health. The next step is to establish occupational exposure limits. These are maximum chemical concentrations that can be exposed to in the workplace. They're known by various names. In the UK, they're workplace exposure limits. In Australia, workplace exposure standards. In the US, they're permissible exposure limits. And in Germany, they're maximum allowable concentrations. While they have different names, they serve the exact same function. On the screen is an example taken from the UK workplace exposure limits. This is representative of the majority of occupational exposure limits. The table would typically contain hundreds of chemicals, but I've just taken a few as an example on the screen. In the first column, you have the chemical name. But as each chemical has dozens of names, depending on what naming system you use or what language you speak, the second column has a CAS number, which is a registration number specific to that chemical, so you know exactly what you're talking about. The third and fourth columns give exposure limits, assuming you're working 8 hours a day, 40 hours a week. It gives a value in parts per million or milligrams per meter cubed, but this is exactly the same number, it's just a different way of measuring it. After this, we have a short-term exposure limit, which shows the concentration you can be exposed to if it's just for a 15-minute short period. This might be if you've spent all day doing your build and then afterwards you just need 15 minutes for post-processing. As the exposure is shorter, you're allowed to be exposed to a slightly higher concentration. The final column doesn't appear in all regulations, but it lets you know if the chemical is a known carcinogen, mutanogen, or similar to help you with your risk assessments. This legal framework is good, but it doesn't address one of the key concerns of 3D printing, which is the nanoparticles given off. So where could this be heading? Well, in 2019, in the USA, UL 2904 was launched, which is a standard method for testing and assessing particles and chemical emissions from 3D printing. In the same year, the HSE in the UK released their report measuring and controlling emissions from polymer filament desktop 3D printers. Both of these look at gases and nanoparticles given off 3D printers. And then in 2020, the Nano Harmony project was launched. This brings together 14 expert partners from 10 European countries and will work alongside OECD and ECHA in accelerating the development of priority test guidelines and guidance documents for nanomaterials. It's difficult to say for certain, but it seems like the majority of governing bodies are creating standard tests for nanoparticles and 3D printing processes, which would be the first step in restricting their limits.